I want to talk about a couple of things with relays that are important before we get started. Okay, uh, the relay is a very, very important device, and it confounds and confuses a lot of people. And that's largely because the people who build them want you to change a lot of them, which would require you to buy a lot of them. So they're sort of taking advantage of your ignorance, which is not your fault, by the way. Uh, and they have black covers instead of clear covers. And part of the reason is that you can make black plastics a little tougher for less money than you can make clear covers. But relays do come with clear covers. So this one would have a clear cover if it hadn't been broken when somebody took it off. But the point here is that you cannot be afraid of a relay, and you cannot get into this habit of playing relay roulette where you swap out all these relays and and let's change this one out and see if this fixes it and put it, the problem is if you don't know where you are in the system. Notice I said system and I didn't say circuit. You need to use that word more often than you say circuit. Notice that the relay is a fairly small object, and it's fairly simple. Okay, they all do exactly the same thing. There are slight variations on the theme, but for those of you involved in hunting, 30-06 and a 30-30 are similar, but they're different. You know the difference by looking at them. And in this particular case, you need to apply that same sort of rule and look for small differences. But the first thing you should do is assume that they're all the same, and they are. This is what people call an ISO relay. All right. I guess this one's usually called an automotive relay right here. These are called ice cube relays because they've got clear plastic covers, or mostly do. This one has a really good clear plastic cover if it weren't in 47 different pieces. Now, the covers of my relays get taken off non-stop because mechanics go to the part. That's a bad thing when it's electrical, okay? Because in an electrical environment, the last thing you want to do is go to the part because it's only going to fail about 20% of the time. Let me start with this larger one, which is called an ice cube relay. And let me start on the bottom here. See if I can put them in here where you can actually see the markings, I think. This, while being a little beat up, is a 3-pole double throw relay because it has 3 separate switches identified by these barricades. And that's one of the visual cues you need to look for. Okay? You're very skilled at looking at visual cues, and you shouldn't pick something up that's electrical and immediately forget all that. So if you look at this, there are patterns everywhere. The first and most obvious pattern is that there are these barricades splitting up and dividing these terminals. Okay. The next thing I notice is that every relay has a coil, and a coil only has 2 wires in and out. So here's the coil. They're set off by themselves. All right. Then, if you look at these terminals here, you'll notice that these 2 terminals here are a little bit further away than these 2 terminals here. And that's because these 3 are the common. Okay? And the common is called the common because the common is shared by these 2. And the word common and community and communism and all those words mean shared. So here's the common, which is not the ground. Common does not mean ground. Common means shared. So this terminal and this terminal share the common. And the 1, 2, and 3 are the normally closed, and that's because the spring pulls the contacts forward to touch these terminals here, And then when we energize the coil, the contacts move back and touch these, which are the normally open. Okay, that normally openness and normally closedness never change. Whatever the relay is in your hand, that's normal. All right. So there's some patterns here, and then there are other cues. If I can, I think you can see that. Notice that these are numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, but these are letters A and B. Well, that's good because on a schematic, if you see a coil with an A and a B, you know it's this relay. Okay. And if you know it's this relay, then you know it's going to have 3 switches and so forth and so on. Okay. Here's the base for it, and it matches, but it's a mirror image. That's important, mirror image. But here's your A and B, and here's your 1, 2, 3, 4, 5, 6, 7, 8, 9 in reverse because the relay goes the other way. So there's 1, 2, 3, and if we flip it over, it's 1, 2, 3. Don't ever forget that. Well, this is cool because it gives you access to the whole system. These relays are really easy to work on because you've got all these terminals just exposed, and you got terminals exposed, and it's a pretty straightforward relay. Another style is this style that has a circular base, and there's a key. All right, there's the key, and again, it's a mirror image. I'm going to give you a clue here, and at some point you may want to pause this. If you work on this type of relay or have this type of relay, you may want to pause this because it's kind of interesting, and replay it over and over and over again. There's a pattern here as well, all right, and it goes 1, 2, 3, 4, 5, 6, 7, 8, and engineers do that. Okay, so there's never going to be a time where an engineer doesn't do that when they can. So 1, 2, 3, 4, 5, 6, 7, 8. All right, this is a 2-pole, 2-throw relay. 2 poles, 2 throws. This one was 3 poles. All right, but this one's 2. Double pole. I call it. I use numbers. It's easier for me anyway. Well, the first cue is that 7 and 2 will always be the coil. Okay, so the coil are always the 2 bottom outside terminals if this is installed properly. Okay, so you have to pay attention to your numbers. 7 and 2 are the coil, and this is a diode that's across the coil, which we'll talk about at some other point, but this is here for arc suppression, and it has to be installed in a particular way. For those of you who'd like to look it up in the book, it has to be installed in reverse bias. Okay, so it goes 1, 2, 3, 4, 5, 6, 7, 8. Well, if you cut the relay in half, right, cut the relay in half here, then we've got a common, a normally open, and a normally closed, and there's 2 of them. Well, these are the 2 commons because they're down here by themselves, and there's only 1 of each. And then these 2 terminals are the normally closed, and these 2 terminals are the normally open. So it goes up, divides in half here, positive and negative of the coil in that order. If those are backwards, there's a diode that may not turn on telling you what's going on. So the polarity is typically 7 positive, 2 negative, left to right. Okay, so this is one switch here, and this is one switch here. So you got click and you got click, and they both happen at the same time. So the relay base and the relay has a pattern, all right, and patterns are everywhere. So if you see a coil that says 7 and 2, well, it's this one. Okay. Here's the little ISO. I'll do it next and do the other one last. These are just used because they're smaller. It was determined that you didn't have to put this one in when you could put this one in, and there's less material here. It weighs less, so it costs less to manufacture. But they still had to come up with a pattern. All right. So if we put it in, we look at the base where we plug it in, left to right. These 2 terminals out here on the side are the coil, and notice they're going this way. And then these 2 terminals here, notice, are slightly larger, meaning they can carry more current. Well, these are your 2 switch terminals, and it's 3 and 5, and 3 is the common, and 5 is the normally open. And this little scutter in here is the normally closed, which may or may not be used, and very often is not. In fact, I've replaced the relay on my son's car that had this one for the horn, but it didn't have this slot, so I just took a pair of side cutters and snipped it off and ripped it out and used this one of these, fixed it. Really pretty straightforward. But there's a pattern because the two coil terminals are going this way and the two switch terminals are going this way, so you can see the visual cue. These two terminals are bigger, these two terminals are smaller, and then 4 normally closed, kind of it has to be stuck in there somewhere. So they stuck it in there. Any rate, there's a pattern here as well. And again, it's a reverse mirror image from the base. So if we plugged it in, we'd have 1 and 2 left to right, but because the relays it's 1 and 2, and there's a pattern. How you remember it. Remember it any way you want, but the point is that these 3 terminals down the center are the switch. Okay, that's this part right here. So the switch part are these 3 terminals here. They're also made of copper, which is more expensive, and hence they're more expensive to make, but they need the copper for better conductivity. And these 2 terminals, which are the coil, 85 and 86, you can tell they're made of silver compared to copper. Okay, so there's a pattern there. So these 2 terminals are the coil, okay, and it's 85 and 86, but when you flip it over and you plug it in, it's 85 and 86, okay? So if you always look at the relay this way and you orient your brain to it this way, then it's a lot easier, in my opinion, because this becomes 85 and 86 left to right. That's the coil. And then you got 30 and 87, which are the normally open. And if you jump from here to here with your amp meter, you run the thing. And if you plug your voltmeter in here and just push the switch, you read voltage. So you can check, a lot of stuff at this relay base. We'll talk about that a little bit more. So at any rate, this relay typically requires less than 0.2 of an amp to run the coil. You can run them with a 9-volt battery, and you can test them with a 9-volt battery. But the contacts, depending upon normally open or closed, can carry anywhere from 30 to 50 amps. So you can switch 50 amps with 0.2 of an amp, which is part of the reason that it's that we use it. It's called a relay because it relays a signal. Okay, and in the older days of telegraph, then in the telegraph era, you'd have your city here, and we'll just call the city, whatever we'll call it. I like, let's say Detroit because Henry Ford and cars and whatever. And let's say Dayton, Ohio, because I like the Wright brothers and they did all their stuff in Dayton. So here's Dayton. All right, so to get from Detroit to Ohio by telegraph, it wasn't possible to get there with just one signal, okay? And the reason is that there were voltage drops, and this is one of the cool things about this subject is that there's a reason for everything, okay? And the voltage drop in the wire was so great that it would only go so far. All right, so the telegraph wires would come into wherever they're coming into, but every 30 or 40 miles, because of the voltage drop, there was a relay station. And in that relay station, there was actually a relay. So what happened is that these 2 wires would come in to the coil. So this telegraph key would go, and all it was doing was make this thing going click, click, clickety, click, 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 clickety, click, click, click. Okay? Well, then these 2 terminals were connected to other batteries, and then those 2 terminals sent the signal here. Okay? So that's the story of the relay, and it means exactly what it says. You've done a relay race, so it passes off the signal. It relays the signal. So there would be one of these every 30, 40 miles or so. And I'll tell you this, if you live anywhere where early industrialization existed and there were telegraph lines, if you can find any of these old relay stations, there may be glass jars in here that were battery cells, and they're really, really valuable. So if you live anywhere near any of that, you want to kind of go out and start, hunting for those things. I would definitely acquire those if you could, because they're very very valuable. At any rate, this little device right here that confounds everybody has been around for over 150 years. So you are no longer allowed to be confounded by it. You must understand it. And I'm going to show you some cool things about it. So there's sort of the intro to it. And the next section is going to be, next video, probably video B, is going to be starting on the card. And there's some other things about it that you need to understand too. So that said, let's move on to the next video.